Hi, my name is Dory Welch, and today I will be presenting on rotavirus. On the left, you can see a common treatment for the disease, and on the right is a picture of the disease, or the infectious agent. So a brief introduction for rotavirus. It is the most common diarrheal disease in children, to such an extent that an estimated 95% of kids worldwide will be infected by the rotavirus by the age of 5. The disease is commonly associated with gastroenteritis, which we all know as the stomach flu, even though the infection has nothing to do with the infectious agent for the flu, which is influenza, the influenza virus. However, they do have similar symptoms, so that's going to include things like diarrhea, cramps, nausea, vomiting, and fever. Rotavirus, the infectious agent for rotavirus is rotavirus A. And to go more into that, we can see the classification for the virus. So it is of the family Reoviridae. And we'll go more into the structural characteristics of that family in the next slide. We can see that the genus rotavirus has multiple different species, A through I. However, the one that is most commonly the infectious agent in humans is rotavirus A. So some structural characteristics of rotavirus. A little fun fact is that the name rotavirus is derived from the Latin root rota, meaning wheel. And as you can see in the picture above, is that the proteins on the outside of the outer capsid kind of look like the spools of a wheel. Reoviridae family is defined by several characteristics. So that would be the lack of a lipid envelope, so it's a naked virus, double-stranded RNA, and multi-layer capsids, of which they are the icosahedral shape. So there's going to be an outer capsid, an intermediate capsid, and an inner capsid. Transmission is going to be by two different things, the direct contact route or the fomite route, and that is going to happen via the fecal-oral route. So that's going to be fecal matter getting into your mouth. And these viral particles shed at very high concentrations, so places that kids are running around a lot and grabbing and jumping things and putting things in their mouth. So the ball pit in the top picture is a wonderful example of a germ-infested place where rotavirus is sure to be. These particles are in super high concentrations. So feces have more than 10 trillion infectious agents of rotavirus per gram, and that is more than enough to surpass the fewer than 100 of those infectious particles needed to actually develop an infection. We see that the only reservoir is in humans, and it will occur mainly in the GI tract or in the stool. And again, with the fecal-oral route, the virus will usually enter through the mouth, so kids putting things in their mouth without washing their hands. And viral replication will occur in the villus epithelium of the small intestine. So the villi are really good for increasing the surface area to increase absorption for food and those sort of things, and nutrients from food. However, it does also provide more space for entry of and replication for the viral infection. Some symptoms that we see, they usually present themselves after 48 hours of infection. So symptoms include things like severe watery diarrhea, vomiting, fever, and abdominal pain. And the thing we most are concerned about actually though is the secondary symptom of dehydration. And so that can take the form of decreased urination, dry mouth, throat, dizzy spells, crying with few or no tears, and unusual sleepiness or fussiness. And I would like to note that even though children are the ones who are most likely to present with rotavirus, we do see the infection in adults. However, they usually do have much milder symptoms and are less severe, less likely to be fatal. Diagnosis, so there are lots of different causes of diarrhea. However, if it was important to confirm rotavirus, you could do so by an enzyme-linked immunoassay. So that's where you're going to use particular antibodies to make the diagnosis. However, that is actually kind of rare because if we look at the treatment, There is no specific antiviral medication that targets rotavirus. In fact, treatment will consist of a nonspecific treatment targeted at combating the symptoms of dehydration. So a really simple way, if you're a parent at home, would be just to make sure that the kids get a salt or sugar solution. A lot of times you can run to the store and pick up some name brand drink like Pedialyte if you needed to and didn't know how to make that salt or sugar solution. However, sometimes if that doesn't work and the dehydration is really severe, the child will be hospitalized and fluids can be administered via an intravenous solution. And lastly, even though it's not actually as much of a problem here in the United States, we'll get into problems elsewhere in the world, that there are cases where rotavirus is not caught, is not treated, and the diarrheal symptoms are not treated, and that's when rotavirus can prove to be fatal. So here are some at-risk populations. We can see, first and foremost, we're going to be mainly concerned about kids ages 3 to 35 months. They're the ones who are, their bodies can't fight off the infection, are really going to take the dehydration very hard, and they're also going to be the ones who are putting things in their mouth without washing their hands more likely. We do see other at-risk populations, including the elderly, immunocompromised, and caretakers of infected children, so that can be parents or teachers or nursery workers. For prevention for Rototec and Rototrix, we have 2 different vaccines, and I would also like to note that other preventative measures, such as like cleaning, so Lysol and all those sort of things, actually aren't going to be very sufficient to stop the spread of rotavirus, because we can see, just comparing transmission rates between the developed and developing countries, that there is no increase in disease spreading despite improved sanitation measures. So the main prevention is going to be one of these 2 vaccines. So there are 2 vaccines. The first would be Rototec. It was approved by the FDA in 2006. It contains 5 reassorted rotaviruses developed from humans and bovine parent strains. It is administered orally. And there are 3 doses that a kid will get at 2, 4, and 6 months. And there is an increased risk of interception, which I will get to in a moment. And then there is Rototrix, which was approved by the FDA 2 years later. Also, it contains an attenuated human rotavirus strain, and like Rototec, it is administered orally. However, it only has 2 doses, which will be administered at 2 and 4 months. And so going back to the risk of interception with Rototec, that is basically a condition where you can kind of see in the picture on the left, or on the bottom, where a part of the intestine will telescope itself, basically causing a bowel obstruction, which is never very good. So as we have learned in this class, is that vaccines are very, very helpful, and we have definitely seen the improvements these 2 vaccines have made. So before Rototec was introduced in 2006, it was estimated that roughly 3 million infections every year were occurring in the United States. And that's where I got the first statistic, where 95% of children globally had experienced at least 1 rotavirus infection by the age of 5. However, post-vaccine, we see that the threat of these cases has significantly gone down, to the fact that in countries like the US, like the CDC is not having doctors even notify them when they come across a case of rotavirus. Hospitalization has been estimated to decrease by 40 to 50,000. And again, that's also kind of hard to measure, because it's becomes such a less problem, is that we're actually not even collecting that much data on it. And so like a great example of that would be like in the 2011 to 2012 season, it never even met, the number of cases never even met the threshold or the minimum number of cases to signify the start of like the uptick of rotavirus and indicating a rotavirus season. And you can actually see that in this picture. It's just been increasingly going down. And you can see that is where the vaccine was introduced. And again, another pretty big dip after the second one, Rotavirus, was introduced. And so I'd like to end this presentation just kind of saying like we are very lucky here in the US in that we have a pretty well-developed medical infrastructure. However, that is not the case everywhere in the world. The World Health Organization estimated that roughly 250,000 children have died just in 2013. So that's kind of a very sobering thought, is when we think of a kind of easy treatment that could prevent these deaths is just clean water with sugar or salt, and all these children wouldn't have had to have lost their lives. So we can look at different rates across the globe, and so a national estimate of rotavirus attributes, so in places like India, where there are 47,000 cases, to fewer than 5 deaths among 79 different developed countries. And we see that 10 developing countries accounted for almost 2/3 of all deaths in 2013. Just a thought to think about. I appreciate your time. Thank you so much.